Excuse me.
Yeah?
I'm really, really attracted to you. And according to Newton's laws of gravitation, you're attracted to me too. Well then, I suppose you guys need to understand the physics components of Newton's laws, instead of my failed attempts at a pickup. At the end of the 17th century, Sir Isaac Newton proposed 3 physical laws that describe the relationship between the forces acting on an object and its motion due to these forces.
The first law of motion, otherwise known as the law of inertia, states that an object at rest remains at rest as long as no net force acts on it.
That's correct, Tom. And the same is true for an object traveling at a constant velocity. For an object to be slowed down or stopped, a force would have to be acted upon it.
Many scientists preceding Newton, such as Aristotle and Galileo, tried to prove what Newton successfully proved with his first law. Aristotle first claimed that an object is at its natural state when it is at rest. Furthermore, Galileo recognized that a force is needed to change an object's velocity, but no force is needed to keep it at a constant velocity.
I think that it is necessary to mention the force of inertia when discussing this law, right, Tom?
Easy there, cowgirl. Inertia is not a force. In fact, it is the tendency of objects to resist changes of motion. It makes logical sense when talking about the first law of motion, though. You can see inertia applied in the following clip. As you can see, no force is acting on the egg itself. Thus, it will drop straight into the glass. Another example of Newton's first law is me kicking Ryan in the head when he's least expecting it.
What up, man? How's it going?
That's on.
How'd you do on that test?
Did very, very, very bad.
Really?
Yeah.
Staying after school today to work?
Yeah, I'm gonna do a couple practice problems right here, so.
Sounds good, man.
Alright.
Yeah, man, I heard Tom Sewell didn't do too well on it either.
Really?
Yeah, I don't know what his deal is. It's kind of sexy. Oh! What the?
Shaboom!
What the hell, man? Ferris, I'm coming back from the nurse's office. That's not cool, man.
Man, I don't really care, bro.
If you don't mind, I'm going to talk about Newton's second law.
I don't mind.
God, man, it hurts. Well, here we go. I'm going to talk about Newton's second law now, if you don't mind. The law states the sum of the forces will equal mass times acceleration.
Well, great. Here I am thinking we're finally getting rid of equations. Curse you, Newton.
Easy, Tom, easy, Tom. Let's try a short demonstration to tease your intellect with sophisticated knowledge.
The acceleration depends on the object's mass and on the net force acting on it. So in a nutshell, objects with a smaller mass accelerate faster than objects with a larger mass.
The sum of the forces of the two objects, in this case the girls, is always equal. The demonstration illustrates that the object with the less mass will have a greater acceleration, and the object with more mass will have a slower acceleration. Another common example is the force of gravity accelerating an object towards the center of the Earth. Here, Tom, let's try to apply Newton's second law. Alright, Tom, let's test your intellect here. One overweight ice skater, Tom's identical twin brother, Chaz, pushes off his partner, Jimmy, during their ice skating routine. Chaz has a mass of 88 kilograms and Jimmy has a mass of 62 kilograms. If Chaz accelerates with a magnitude of 2.37 meters per second squared, determine Jimmy's acceleration.
It's a great question, Ryan, and I don't appreciate that little insult you threw in there. But, so, using our givens, our initial equation that we will use is force equals mass times acceleration, which is a tenet of Newton's second law. By using this equation, we will be able to find the force of Chaz. So the force of Chaz equals his mass, which is 88 kilograms, times his acceleration, which is equal to 2.37 meters per second squared. After computing this in our nice calculators, making sure radians is off, of course, our final answer is 209 newtons. Now, in Newton's third law, which we'll be explaining later, we know that the forces are equal. So to find the acceleration of Jimmy, we use the same equation. Force of Jimmy is equal to mass times acceleration. And so since we already know the force, which is 209 newtons, we equal that to his mass, which again is 62 kilograms, times A, which is the acceleration that we're solving for. So A is equal to 209 newtons divided by 62 kilograms. Now, the final answer for this problem, while using significant digits, will be 3.4 meters per second squared. And that, Ryan, is how you do some physics problems.
Nice going, man. Nice, bro. Care to share your knowledge about the third law? This is the only encounter I've had with this third law. Newton's third law of emotion. For every male action, there is a female overreaction.
Funny you should say that, actually, because although the idea is right, there is not an overreaction to a reaction. Newton's third law states that for every force that acts on an object, there is a reaction force acting on a different object that is equal in magnitude and opposite in direction. Check it out, Ryan.
The wrecking crew is making a wreck of this offense. The fans are loving it.
Oh my god, oh my god.
I know. Believe it or not, the force acted on each player is equal in that play. Another example is a car on the ground. If the ground did not exert a force back at the car would break through the Earth's surface.
That's interesting, Tom, but how can I remember all of these laws together?
It's easy. Check this out.
An object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion unless acted upon by an unbalanced force. Let's say you walking down the street, cause you're going to the mall, and something knocks you off your feet cause you ran into a wall. So you were acted on by an unbalanced force, which means you ran into the wall and it threw you off course. Oh, I get it now. An object at rest will remain at rest unless acted on by an unbalanced force. Yeah, often called the law of inertia. Yep. Bradley, come tell him about the second law. Come on.
Force equals mass times acceleration. What? Said I had to push a car to the gas station. It weighed 1,000 kilograms and rolls really slow. What? So it would take 50 newtons just for it to go. For real? Oh, I get it. Acceleration is reduced when a force acts on a mass. The greater the mass of the object, the greater the amount of force needed to accelerate the object. Law number 3.
According to Newton's third law, for every action there is an equal and opposite reaction. Which means when you push an object with force, it pushes back with equal force, such as a rocket or a scooter. The rocket pushes down on the ground while the ground pushes the rocket up with equal force. And those are the 3 laws of motion. Yeah.
That'll do it. Those are the 3 laws of motion. Goodbye for now.